Okay, so what we are doing now, we are preparing the chamber for sample processing. We are preparing the chamber for sample processing. I hope you all are in Twitch now because we had some connection problems lately. So, as you can see here, just a moment, that is the chamber below. That collects all undersides. So you can lift it up, please, just to show. So here's the chamber. If you look at it here, there's a flange, and that is the hole that basically is covered by rubber. It's important to understand that this chamber is upgradable to, I would say, semi-continuous mode. There will be a possibility to attach the specific mechanism here that allows to reject some amount of material from the chamber below. We don't use it in the lab conditions, but we just explain why this flange is here, okay? And that is an aperture in the center of the chamber, and you can see there is a bucket underneath that collects all the rejects all the excess output water through the hole here. So whatever water is coming down, it always collects down in the bottom that bucket. So it's all very wisely set up. So it's all clean, it's easy to clean, all the surfaces are open. It's not like in mechanical crushers where everything is inside and you have to be aware of all the contamination all the time, and it's not easy to clean. This is very easy because you can see through any part of the equipment. So yeah, so we'll set it up. There are several gaskets here. The one is O-ring, then another one is so we put it on the gasket. Now we put the plastic bag in it. That plastic bag is clean, new bag, it's disposable bag, so for each sample we use a separate bag. It's very critical due to very fine-grained nature of our minerals of interest. So it has to be an empty, clean bag that we actually always dispose of every sample. So here we have a sieve. This one is a slit sieve, and it's 0.8 to 1 millimeter size. Not very ideal, but I would say that everything that passes through these slits, through this sieve, will go out of the area where the whole disaggregation is going on. So whenever the grain size attains -1 millimeter, it goes through the sieve and out of the explosion area, out of the efficient area. So it gets, from then on, it gets unhindered, not affected. So now we place the chamber, the upper chamber, on its place. So we have two chambers now tightened together by a special latch. So there are two latches from two sides. So it's fixed. And you see the sieve at the bottom, that 1 millimeter sieve, to which we place the sample right now. We have that sample ready. Let's take that sample. Where is it? It's in the bucket. So this is the sample. It's gabbronorite, sulfide bearing gabbronorite. It's actually late intrusion. So it's very rare disseminated sulfide horizon, very, I would say, fine, very small, narrow sulfide horizon that we have to recover. Now we pour water in the chamber with a water hose. We fill up the whole chamber with water, and you can see that the water streams through these slits into the bottom chamber there. So we fill up the whole chamber, the bottom chamber and the upper chamber at the same time. We need to fill up the whole volume with water. It's about 40 liters of water, but we can fill it up half, like 20 liters. So it's a little bit more than one drinking bottle of water, I think, or one bowl of drinking water. That be more correct. So a little bit about the equipment itself. So this is high voltage power supply that produces 50 kV AC. We then deliver that 50 kV through the breakage system to the bank of capacitors of the max generator with the certain air gaps in between two spark gaps. So each one corresponds to each number of kilovolts for the threshold. So these capacitors are connected in parallel, but they discharge in series. So each time, each gap adds another 50 kV to the actual output voltage, and that output voltage comes up to 300 kV in this chamber. So that this amount of energy all expands into the solids that are in the bottom, in between the electrode, that is the electrode, and that sieve. So all those sparks travel along the as plasma travels through the rock, eventually disaggregating it, and once it's disaggregated, it comes through the sieve. That's as simple as that. This, I would say, breakage system, high voltage breakage system, allows to discharge capacitors. All the residual charge of the capacitors be discharged whenever the system is offline. So this doesn't belong here, it's just a testing plant here, because every machine that we produce, we test here and then we sell it. Right from here, it's like quality control for some time, like for a few months it works here until we are satisfied and clients can visit and see that this equipment works. So these spark gaps usually covered by the front panel. Those spark gaps are covered by front panel, and here we're not covering it, and there are also holes from one and from the other side to suck up the ozone, because air, once it's affected by spark gaps, becomes the other gases like nitrogen and ozone, and you need to evacuate these gases out of these spark gaps. Otherwise, it gets energized, electrized, and it's working. It doesn't work properly. So, because we don't know where this installation will stay, where will be the exhaust, so we are not making these holes so far, and we work with an open side of the spark gaps. So it shouldn't be like this. But in a way, it's good because you can see the sparks traveling from one electrode to the other. So now you can see that the water is now up to the level. The sample is inside the chamber, sitting there merrily on the sieve. Oleg is closing the chamber right now. Usually we have the window here, and so we can throw the samples through the window. Once again, the client doesn't want it to be done so far because he wants this to be sealed. So we keep it as is right now. So yeah, so this is another precaution here because it's very high voltage equipment. This is high voltage, what was it in English, this one? Rod, high voltage rod, right? So we touch all the current carrying conductors whenever we enter into the compartment, into this, as it's called, Faraday cage, and that blocks all the EMI, electromagnetic fields, from the outside of the equipment, so it doesn't affect any other electronics. And you know that high voltage always affects electronics around it. So you can see that this is perfectly contained. Also, this installation, not like this one, this big one is very, well, what is it in English once again? Noisy. It's very noisy, exactly. So I should put, thank you. So that's why we put the headphones, because it's like a machine. machine gun, the sound is quite loud. Unfortunately, you cannot avoid it with 250, otherwise you have to build up walls, soundproof walls. So Oleg is heating up the capacitors, because the capacitors has to be trained. We need to fill up the capacitors by the electricity and make sure that these capacitors the capacitors will be full. So they will be filled by the energy properly throughout the whole entire volume, and so we have to train them a little bit so the charges will spread properly through the capacitors. So you can see here different numbers. So we are setting up certain kilovolts. So now we are heating them up. The threshold will start be happening whenever we have 50 kV here, because the distance between the electrodes there in the spark gap box correspond to 50 kV threshold, and we know that on air the threshold happens on 50 kV at 3.3 millimeters on air. So some specific distances between these spark gap balls have been set up previously before, so we are sure whenever the threshold will happen. So he's heating up the capacitors for some time to make sure that we have a good steady discharge. As for the buttons, there are button on and off. There are different settings here, and also there is an emergency switch here, and all sorts of different other things that we can explain later. But for the moment, we're just heating them up. It takes a little bit of time, like 5 to 10 minutes. Usually when we haven't worked for the day or 2 or 3, we have to heat them up. That's normal procedure. Once again, it prevents the equipment to it actually gives it more longer lifetime. That's why we're doing it. So we also monitor visually if everything is all right. Once again, all the parts of the equipment work all right. There is no leakage down there, no water streaming down. Everything's fine. So we'll not be doing that test. Yeah, now we discharge the caps. You will see the spark. So that was testing if the capacitors were loaded and there was good connection between current carrying parts. So basically he has lifted up some voltage in the capacitors for some time. Now he is doing the same. We are now having 43 kilovolts. We remember that it will start sparkling, what's it called? It starts discharging around 50 kV. That will be sporadic sparks from the beginning, but then it will be steady. So we're increasing the voltage slightly, slowly, to make sure that you see 0.1 kilovolt a second. So to make sure that the discharge will happen in its certain time, and once it's started, you just continue processing the sample, and we have it all processed eventually. Okay, so we've had several discharges, and now it all stops. Okay, so we want to see what's going on there. Sometime we have to stop and check whether everything's going its proper way. So those precautions, you can see that we can check by this hand rod if everything is discharging okay, and there are no residual charges in the capacitors. So now it's placed on the way so that nobody can enter that Okay, what's going on there? Let's check it out. Now we just place the hand inside and see what's going on. Huh?
Нет, не тут.
Okay.
Тут электрод не влазит.
So you can see that some part of the stone has been already cracked, but not much. So we have to continue. It's just that this is very tough stone. You can see it's very solid. It's not the one that you can easily hammer and make it all crushed. So we have to process it further. So there is no such thing as density or hardness for this process, because it's not physical process. I mean, not actual mechanical process. It's electrical. You see? Maybe we should put it. No, I don't think it's good. Just like this. We just have to have more time for that.
Okay.
Okay, so we continue. It takes some time, this one, because it's very tough. We have to expend more energy on this one. Okay. So we continue.
Не, он там отключен.
Это там задержка.
Ага.
Okay, now we should see what's going on there. It was like a few minutes now, so we have to check after a few minutes what's going on with the sample. You have seen it's very tough, very fine-grained, very compact, very dense. So it's not easy to crush. There is no way that you can crush it by hammer. So hopefully that electrical will be able to disaggregate. Nobody else has done it before, so we have to check. Yeah, it's still here. Nothing happened to it. It means that it's not.
Подожди, вон трещина.
We'll see a little bit of
Crack.
cracks coming out. Anyway, it needs more time on EPD. It needs much more time. It's very, it's very dense. It's like, I don't know, it's like mirror. It's very fine-grained, amazingly fine-grained. Let's crush it further. No way that we can avoid it because clients want the result. If that will be, smaller pieces, you see, that may help, but it's still large, big piece. And yeah, it will be jumping up and down, but we can try. Maybe it will crush like this way. You see, we have to use the whole volume of chamber for this one because we have to place the electrode right on the rock this time. Otherwise, it wouldn't crush. We have to at least make it as two pieces. We don't have a saw in our lab to cut it into pieces, so we have to use EVD for that one. No. It won't work this way, so we will place it back on where it was. You see, each time, every sample, every rock behaves differently under EPD. Maybe for this test training kind of a course, it's not the easiest sample. But then we have that one for the work to be done, so we have to do it one way or the other. So if you have time with us, you can continue watching. It will take a little bit of time to finish. I think we have to place it back at where it was. Just place it back and we'll continue. I think this needs more time. Otherwise, these charges was good. So it's very tough. We have to work on it more. Not like that with other more, I would say, polymineral, many mineral rocks. This one seems to be the same, density. Like there is no difference in conductivities for this one. You see, the separation by electric pulse is done via the conductivities, different conductivities. So here, the all conductive properties of the sample are the same. So just one hertz, not two. Just be doing sessions, like 1 minute session, then stop, then another 1 minute session, and stop. Да. So once again we check. It seems that the sample is too big. So you have seen basically most of it. We'll try and cut it into two pieces right now because it won't be easy otherwise to process by EPD, I think. We'll check if it crushes down. See, this one is very tough. It has never been anyone like this before, so we'll try and check it. It's just too solid.
No, it's still there.
Nothing happened to it. It's still very big. So some pieces were worn down, or this one, not many. But that just because it's very kind of dense, very tough sample. And it should be smaller for this density, for this toughness. It should be, I would say, two pieces rather than one. But we can try it more. Actually, there's no thread now. No cracks. Yeah. So we'll try to cut it by the hammer. We'll try to hammer it now. Глаза. Not very comfortable sample for hammering. No. Not easy. Very uncomfortable. Aha. It's a small piece. No, it's getting loose. It's getting loose because of EPD once again. It's getting loose. Давай как геологи делают, вот так ногу поставь. Okay, it's getting loose. It's easy to crush now after EPD. It's another thing with EPD because you see all the that's nice, very nice. You see, we couldn't actually crush it before, and the hammer was very, you see, less strong than the sample itself. Now all the cracks that was inside the sample become efficient for hammering. So we now can continue doing EPD, but with separate pieces. So one of the very well-known effects of EPD is pre-weakening. So we've seen the pre-weakening effect on the sample. Though it was very dense and tough in the beginning, we were capable to crush it to pieces after some time on EPD. All the boundaries between different minerals, all the cracks that was within the sample, they got loose, and it's easy to hammer and easy to crush mechanically. If there is a case for this specific sample, because definitely we want to replace mechanical crushing by all means. So now it will be more easy to crush it, more easy to do EPD. We'll just need some time. It will be less stressful, and we continue. That's a specific sound now you can hear. Before you have heard the sound of felt discharge, because it was a big sample and it was easy for discharge to come to the outside chamber. Now it all goes inside the chamber, just because the sample is smaller. So now we check the results of 1 minute or maybe 2 minutes of APD on the sample, just to make sure that the process is going the way it should. Oleg is touching all the possible charged conductors, and let's see what's in there. And the smell of ozone here. Now you can see it's all nicely disaggregated. Is it more than that?
Да, там еще полно.
Okay, so we'll process further. So this big sample, big chunk, has been first pre-weakened and crushed to pieces by hammer, and now we have it all affected by EPD. It's getting less and less material on the top. Everything comes through the sieve right now. It's all loose now. It was very dense, very, I would say, tough sample. Even then, it's becoming disaggregated, which is a very good show of the efficiency of EPD. Even for large sample, very dense sample that won't be capable to treat otherwise. I doubt that any mechanical crusher can do that, especially this quick. Yes, we've lost some material when it was hammering, but it's not much. We will have the balance. After we will crush it all, it will still be the 100% sample. It's all, I would say, all the same assemblage. So there are questions, right? Let's check it out. What are the questions? Okay, no questions. All right. Let's continue. происходит?
Когда у двери делали, так же было.
Там сульфиды.
Под разрядом.
У нас электроды остались нормальные, живые?
Вот последний. Там есть еще?
Вы на батарее не убили, блядь, или что?
Кого не убили?
Электроды?
Видишь?
Убили, да? Заказывайте, хули, блядь. Электродов же мы не оставили. Вырубаем. So it seems that the discharge is becoming kind of standard. It seems that there is not much left in the chamber, so we can check if we have processed enough, or maybe we have processed it all. I suggest that we stop for now and basically discharge the chamber so that we have enough material under the sieve for further processing. We don't need to basically process the whole amount of sample, right? Because we still have the balance of the coarse grain and -1 millimeter fraction. We will use the coarse grain for processing further on EPD Spark 10. So this one amount that we've processed through -1 millimeter will already be enough for further wet sieving and hydroseparation. Let's see what we have got there on the surface. How much we have got on the surface? That much?
Еще 3 раза постолько, и там такие крупные в основном.
Should we reject and then use EPD Spark 10?
Я думаю, да.
Yeah. Okay. So we will be rejecting that, or maybe should we process more? What do you think?
Можно оставить как запасной вариант.
Ну, чтобы второй раз не переделывать, как считаешь?
Можно еще подробить.
Ну, хорошо идет вроде, да?
Идет, да. Может 2 Гц поставить.
Okay, let's make quicker, faster processing. We think that we need a little bit more material, -1 millimeter. So if you bear with us for another 5 minutes, you will be able to see how will we reject that amount of material and see what we'll be doing then after that, because we need to evacuate all this material from the chamber. We'll show you how is it done. Bear with us. We will finish shortly. We will make it quicker this time, 2 Hertz. It was 1 Hertz before. We will be making it quicker now. Oleg is setting up frequency. Here programming the device.
Mm.
This is programming the device itself. He needs to set up frequency, to change the frequency. He wants to set up 2 Hertz. Okay. So it's rebooting. It's now 2 Hertz and 50 kilovolts. We start. So now it's moving fast. Хорош, чувак. Не ехать надо. So now we reject all the material from the chamber. It will be the final product of EPD Spark 2. So it's more or less, yeah. You can see little sparks coming down. It's not well discharged from the beginning. So Oleg is checking it up to make sure it has all discharged. Because it's faster this time. It was 2 Hertz. It was 1 Hertz in the beginning. Now it was 2 Hertz. So Okay, so what is on there now? Let's check it.
Сейчас вот нужно все оставшееся Spark 10.
Okay. So the rest can be used for Spark 10.
И еще столько же там
Uh-huh. Okay, so we reject that material from the chamber. That's from the, it's called oversize. So we use oversize and undersize. So this one is oversize.
коричневый какой-то, смотри, крупный кристалл.
Some different minerals here. What?
Он под пальцем большим. Здесь. Он не фокусирует этот стрим, потому что...
Okay. All right. Oleg can see that even different minerals, different crystals, kind of crystal-shaped particles. So it's very important here, since it's batch mode operation, and it's specifically important to keep water, reject water, can also host fines.
Скажи Сашке, пусть придет, он же тоже стрим будет смотреть. Мне надо помогать сливать.
Okay, I need call for another hands, because yeah, I'll be doing the streaming while Oleg needs 2 other hands. I have to.
Нет, ты прям в стриме скажи, Саня, иди сюда. В электроимпульсную.
Just a moment. So we have water coming down from the chamber using the hose. All this water has to be settled down. Those particles have to be settled down because they are still fine, saturated in water. So we either leave them overnight usually, or use centrifuge.
Ну, смотри стрим. Нужна помощь, надо сливать с пакетом. Ведерко подготовь, там 2 ведра. Угу. Не, там. Там? Да. Вот пакет достану, сольем.
Еще что-то картинка иногда будет.
Ну,
Совсем плывет?
Нет, иногда как бы качество теряется, буквально на 3-4 секунды и дальше нормально. Звук хороший.
Отлично.
Все видно. Ну что-то делаете, я так понимаю.
Ну да, плотненько. Ну как с сульфидами.
Ну, да, нет.
So this hose is also, for cleaning. Now we have what's left on the sieve. I'm doing everything by my hand, one hand, no problem. So here you are, that's oversized. That's what's left from that sample, that tough, big sample, field sample, tough, labradorite. So we wash it a bit more in the underside because we need to clean it a bit more. Okay. So that comes to Spark 10 for further processing. So this is oversized, and now we will check how much we get as undersize. under the 1 millimeter sieve. Okay. So we have that plastic bag full of the undersized fraction. We pull it up. It's all there. Need 4 hands to
Вот все есть, звук. Один, видео, один. Сейчас включится. Вот, все.
Сейчас проверим.
So we have that amount of undersize, some in the bucket and another part here in the plastic bag. It's already here.
Давай смоем его все.
So we wash it to another bucket.
Так, значит, смотри, держишь край.
Также вот этот.
Да, чтобы он главное, чтобы вниз не упал. Раскрой пакет. Пониже, прям в бедро его целься.
Clean plastic bag. Anyway, it's for disposal later. Right now we have so much water for settle down together with other excess water and some sample.
This goes to wet sieving
This one goes to wet sieving.
and then to hydro separation
Yes.
for concentrating the full file.
Yes, and this amount will go to EPD Spark 10 into here,
Сегодня?
and we'll reprocess it now. Later, I think, not today, because I'm busy. So thank you guys for watching. There was
See you soon.
see you soon.
Welcome to our
Welcome to our lab. No one else in the world does it. Well, actually, quite a few labs, but we just wanted to show that you cannot see it quite easily. Nobody will show you but us. So bear with us. Next portion of information, whenever you want, we can actually provide. It'll be, I think, I will send you a note. We will be doing EPD Spark 10 on that oversized amount of material. And then we'll reunion it with Spark 2 material for wet sieving and then hydro separation. Thank you very much for your time, guys.